Okay, welcome back. We're on page 252 talking about the hierarchical nature of this phone book service, this DNS service. And basically the way it works is that, for example, the University of South Florida maintains their own little private kind of a scenario, their own phone book for wherever Koba and Islam and www is. So it knows that. But these guys over here don't know it. So if I want to get to usf.edu, I basically have to ask my guy, do you know how to get there? And he goes, no. He goes to here. This is the root. And then the root knows what's called the top level domains, TDLs. There's even an acronym for it. The top level domains, and they maintain a list of all of the other address books. So this top level domain doesn't actually have hardly any PCs in it. It basically has a list of all the rest of the phone books. So it's like calling directory services at the United States and say, I'd like a number in Texas. They go, pardon me, let me forward you to Texas. And so you get the Texas one. They say, hey, I'd like a phone number for somebody inside Killeen, Texas. They go, and they forward you to somebody in Killeen. And the Killeen person says, hey, I'd like to have a phone number for this guy in Killeen. He goes, sure, no problem, here it is. All right, because the top guy doesn't know. The next guy down doesn't know. And so finally, you get somebody who goes, yeah, I know who that is. And so it gives you the answer. So it has to traverse lots of trees to be able to pull this off. Now, why did they do this in a hierarchy? Well, because one person can't be in charge of all that. So the people at the University of South Florida, they have to maintain their own somehow. And so these guys maintain their own, and these guys maintain their own. And so it's not up to one person to maintain the phone book. That would be incredibly dumb. Cool? Makes sense. All right, let's do some things. So I'm going to do a lookup. So I did when I did a ping to www.emmettgray.com, it basically told me kind of what it is. But that's sending traffic back and all the rest of that stuff. What if I just wanted to do a name lookup without actually talking to it? Just explore that path back and forth. There's a thing called NS, name service lookup. And then you could tell it whatever you wanted, like www.emmettgray.com. And it'll just go to the guys and say, here's what I think the answer is. And so he goes up, asks the server, and the next server asks the server, and the next server asks the server. And there's a cool way, if you knew that there was a server out there, a real DNS server, you could actually tell it, please perform this services at this phone book. Okay, not any phone book anywhere, not the default phone book, because I'm trying to test this phone book right here. So I would, instead of typing this, I would type in some number, which in this case is not going to work. So, some number here, that would be specifically to go to that location and ask that machine to perform the lookup for me. So NS lookup is pretty good for trying to find the mapping. It also is pretty good for kind of diagnosing things. There's another way you get. I'm gonna go ahead and hit return here and see what it says. It's probably gonna say, "Are you nuts?" Let's see what it does. Yeah, it's probably gonna come back and say, dude, I don't know who that is. Okay, cool. There's another one out there called Nets. There's an IP config, and then there's a thing called Display DNS. And Display DNS is going to list all of the names that it has cached up, because I don't have to look it up every single time, do I? Wouldn't it make sense that if I asked for a particular name and it returned it, to just kind of remember that for next time? Wouldn't that make plenty of sense? Well, that's exactly what it does. Each machine stores up a listing of every place it's been to. So here's the places I've been to since we've had this video going. And one, including in here, is the time to live. Now, none of these are getting very old, but typically what happens is these guys basically last about 15 minutes. Not surprising. It's very similar to the timeout for the ARP table. And there could be some logic behind that. I haven't really noodled it out yet. But it could kind of make sense that when you go to make sure your IP address is still real, then that's the time you go and get the phone book going. Kind of makes sense. All right. So let's talk about some things that are not in the book. So let's talk 2 DNS features that are not described in the book. Number 1 is, how the heck do I get my machine into the DNS server? Well, in a typical environment like a home environment, the answer is you don't. Why? Because you don't want people to get into your DNS server. In other words, I have a DNS server sitting here on my desk that's providing me information about all this good stuff, but it does not answer requests coming in from the inside. So I don't care. Does that mean that I still have to, I don't need a DNS server? Well, yeah, I do, because I want to talk to my laptop. So it's the same scenario. I don't type in some IP address to get to my laptop. I type in whatever its name is. And so the laptop's name is, I don't know, Gray Laptop. So Gray Laptop number 42, I type that in, the machine goes, hang on a second, let me go look that up. Oh, well, that's its IP address. So I still need a DNS server. So how did it get there? Well, the answer is most DHCP servers, when they issue you an IP address, they'll turn right around and store that answer that it got into a DNS server. So by allocating an IP address, you told it what your machine name was, and so it now knows the machine name and the IP address that it just gave you, so it can store that into a DNS server, and it's all automatic. No one has to go in and manually maintain the phone book, because it's all done through DHCP typically. Now, again, this is a private DNS server that's just for me. So you might think, well, wait a minute, why, if I have a cache here, why do I even need to go there? Because, I mean, geez, when I go to www.emmett.gray.com, it's always going to be providing me the same answer. That's kind of crazy. Well, that's true. If you only had one PC on your network and one router on your network, you're absolutely right. The machine could take care of it all. You don't really need a DNS cache in your router. But if you got 5 machines running on your home network, and all 5 of them decide to talk to www.emmett.gray.com, even though it might be in the cache on my machine, it may not be a cache on my wife's machine. So when she hits it, it's going to go to the local DNS server. Local DNS server says, I already know the answer. I'm not going to bother to look it up. Here it is. Boom. So yes, DNS servers cache themselves and the machines cache, and that's perfectly okay. All right. One more thing we need to talk about that's not in the book, and that is, can you think of any reason why I would want to have some sort of DNS poisoning going on? Now, that's a poor choice of words. Some place where instead of truthfully answering every single time, perhaps there'd be a scenario where I want to lie, where I look up a name, whatever it is, www.kumquat.com, and then in this one instance, don't give me the correct IP address. Instead, give me a fake one. Would that ever be a good idea? What do you think? The answer is yes. Here's an interesting way to cut down on spam and those pop-up ads. When you go to a website and you click on something and there's an ad that pops up, it's going to, adservices.com. I just made that up. So if you had a special DNS server that had a list of all of the spammers, it would look adservices.com, and instead of giving the browser the correct answer, it gives it the loopback address, and therefore you don't get any pop-up ads. Isn't that pretty cool? So there's some out there. There's one called OpenDNS. There's lots of others out there. And so, yes, instead of using the real DNS server, the one probably provided to you via your internet service provider to your home router, that's typically the way it works, right? Whatever, in my case, Time Warner provided a DNS server to my router. My router says, thank you, I'll be a proxy for you, and so I'm your DNS server now. but in reality, it 99 to 44, 100% of the time, it doesn't know the answer, and it goes and asks what Time Warner thinks. That scenario, I could have hard-coded a DNS or gone to my router and said, don't issue the standard one, issue this one by itself. So OpenDNS, you might want to look it up, an excellent way of combating unwanted pop-up ads in your browser by deliberately not telling the truth. Whenever it's asked to resolve the name of one of those ad services companies, it lies. All the rest of the time it tells the truth, but it only lies in that one case. Pretty cool. Okay, well, let's move on. The last section on page 259 talk about your home network. And I'm not going to go into too much detail, but let's just talk about what these things that we call routers, what they really, 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 really are. Okay? They're a marvelous piece of equipment. So I have a router, and it's a router. Okay, it does routing for a living. Woo! Cool. It also is my DHCP server. So it's a local DHCP. It provides IP addresses to all my machines inside my network. Cool. It's my local DNS server or proxy. In other words, all my DNS server go to it first. And just as I mentioned, 99, 44, 100% of the time, it's not going to know the answer. And it'll have to go to the real one, but it's okay. So it provides DNS services. It provides NAT services. So I have one IP address coming in and have practically as many IP addresses as I want on the inside. And by the way, these things are typically turned on by default. You don't have to do anything, right? You don't have to ask it to be a router. You don't have to ask it to be a DHCP server. You don't have to ask it to be a DNS server. You don't have to ask it to do NAT. That's right out of the box. Nothing to do. It's also an Ethernet switch. Again, you don't have to ask for that. It comes right out of the box. It's a Wi-Fi access point. Yep, out of the box. I don't have to do anything. And it's a firewall, which we'll talk about in some other scenario. And the firewall is pretty cool because it blocks unwanted traffic coming in. And it's pretty easy to do a firewall when you're natting, because I have an incoming packet. The way NAT works, this is a little weird. The way NAT works is every NAT packet has to originate from inside the network. Okay, there was no such thing as an unsolicited IP address coming in, because if you just had an unsolicited packet coming in from the network, it would look at it and go, well, there's no NAT tag on this thing, so I don't know what the heck to do with it. I'll throw it away. So one more time. All conversations in a NATed environment must start from inside the network. All conversations must start there. Cool. Now, does that mean that I can't host a website on my machine, on my local network with NAT? Yeah, that's kind of sort of exactly what I'm saying. Yes, you can tweak your NAT to basically, there's a way you can go in and say, if I get an unknown packet in here that doesn't have a NAT header attached to it, just flood all that to this one machine. Yes, you could do that, but that's not what I'm talking about. I'm talking about the way it normally works out of the box. So, okay, one more time. Things that your router does for you. Okay, it's a router, it's a DHCP, it's a DNS, it's NAT, it's Ethernet, it's firewall, it's Wi-Fi. Cool? Okay, we've reached the end of this chapter, and we'll see you again in some future chapter.